Greetings again from Insanity in a Connex, and today we're doing It Came from the Crypt, which is my other storage container of junk. And the subject is the Milman Leadscrew tapping machine, which is a relic of days gone by, but still useful. So it's a little automated tapping machine for doing up to about number 10. It's probably a little low on horsepower for number 10, but its cool feature is it has a lead screw that advances the tap, synchronizes the tap so that there's no up and down load. Like if you're tapping a really soft material, like aluminum or Teflon or something like that. If you wanted to cut tap Teflon, in double aught 90 thread, this would be the way to go. I've got a job running here where I've got a whole shitload of 540, number 5, 40 thread holes in steel tapped full depth. I don't know where people come up with this shit, but tapped all the way to the bottom. And so I'm roll form tapping it. This is an OSG High Pro. These are pretty good taps. Basically, you'll break them off before you wear them out, or at least I do. So to run this machine, a little bit more on it. It took a little bit of figuring out, but it wasn't that complicated. Basically, it's geared. There's a chart, and it tells you, how to set the gearing up, and it's pretty ingenious. Once I kind of figured it all out. So the lead screw itself is a 32 pitch thread, and so what they came up with is they're driving the pitch on a differential motion from the drive. So you have this fixed nut here. So you have every revolution of this lead screw in the nut, which is the spindle, is 1/32 of an inch, whatever, 31.5 thousandths. But that's, so if you're tapping a 40 thread hole, which I am, you need a fraction of 32 threads. And so the way they do that is they have essentially a set of back gears. You've got one ratio here and another ratio up top. And the up top, you've got a set of change gears so that you can, back to the chart, you set the top up, and then you arrange your bowl gear up or down, or in the case of 32 threads, disengaged. So what I figured out, so for cutting 40 threads, which is where we're at, for every 5 turns of the spindle, the nut makes 1 turn. So if you do all the math on that, you'll figure out that gives you a inverse of 40 threads, whatever the heck that is, 25 thousandths lead. Nope. 25 thousandths lead. So you've got your there. I mean, you got to have a differential ratio in there. Is what I'm getting at. And it does it with this double set of gears here that they're not matched. You've got a different ratio here than you do here. I'm doing a pretty piss poor job explaining this, but as you can see, the nut's turning at some speed, and the spindle itself is turning at a different speed, and so the difference of the nut speed from the lead screw speed gives you your up and down feed. So like I say, that's 5 turns to 1 turn for 40 threads. All the other ones are there. The only neat one is for running a 32 pitch tap. If we go back to the chart, it says center bow gear. And so what you're doing then is you're taking the nut out of gear. So if you you gotta lock there's a little pin lock there. So now the nut is completely locked, and the spindle just turns, and it actually tells you to change the gears here to give you some mechanical advantage, because I found out this thing's pretty low on horsepower. But as you can see, so the nut is locked, the lead screw is the spindle is just hard coupled to the 32 thread. And so for all your other threads, you've got some variation of that. So we'll go back to 40 threads here. There's a little indent there. So like I say, for every 5 turns of the spindle, you've got 1 turn of the nut. Otherwise, so it's got some limit switches for up and down. It's got a clutch here. It's a little universal AC/DC motor. It's running off a Variac. It's got a bunch of features I haven't figured out, but for the standard mode, you've just got the pedal, and so it makes 1 cycle. And what I figured out is it'll repeat within about 5 thousandths on depth, actually a little bit better than that. And I think what happens is actually the frame flexing up and down. I still haven't figured out what the other pedal does. There's a cycle interrupt. Basically, you need more hands and feet, though, than you've got if you're trying to hold a part. But other than that, a pretty oddball little machine from back in the day of all mechanical motion control. Like I say, I wish it had a little more horsepower. It's 540 form tapping at, I think I'm just under 60% thread is kind of all she wants to do. The motor just bogs. Let's see, we'll tap some holes here. Yeah, you see me stalling out. I think this plate's done. I'm using like Way Lube sticky, not cutting oil, because it's a roll forming. Is not a cutting process. But like I say, I dug this thing out because I had this job to do. I got a few of these plates to make. I got 39 tapped holes in them each, and bottom tapping, blind tapping 540 holes, even with a tapping head, was kind of like not something I wanted to do. And I had this in the junk collection, so I got it out, and so far so good. Speeds the job up, makes me not sweat so much. course, I got it screwed up. And I don't know, these aren't structural, so it's a low percentage thread, but it's a little better than 60%, I think. Or it's a little less than 60%. I think it was like 58% theoretical, which is plenty for a little fine tooth pitch thread. So lots of tapped holes, and a neat little antique machine. Maybe somebody will find it interesting. Alrighty guys, till next time. Bye-bye.